just 39 seconds. That was all it took for one of the most devastating natural disasters in Venezuela's recent history to unfold. On the evening of June 24th, 2026, two powerful earthquakes struck northern Venezuela, only 39 seconds apart, turning ordinary streets into scenes of destruction. Buildings collapsed within moments, roads cracked open, and terrified residents rushed into the streets as clouds of dust filled the air. Families became separated. Emergency sirens echoed across cities, and rescue teams immediately began searching for survivors trapped beneath the rubble. According to the U.S. Geological Survey, USGS, the first earthquake measured magnitude 7.2, followed just 39 seconds later by an even stronger 7.5 magnitude quake. Seismologists describe this rare phenomenon as a seismic doublet, two major earthquakes occurring almost back-to-back on nearby faults rather than a single large quake, followed by smaller aftershocks. Because the second rupture occurred almost instantly after the first, it dramatically increased the level of destruction and gave people virtually no time to react. The hardest hit areas were in northern Venezuela, particularly La Guaira and communities near Caracas, where numerous buildings suffered severe structural damage. Roads were ripped apart, power and communication networks were disrupted, and thousands of people were forced to flee their homes. Rescue workers raced against time to search collapsed buildings, while hospitals struggled to treat the growing number of injured victims. The disaster quickly became one of the country's largest emergency responses in decades. But why were these earthquakes so destructive? The answer lies beneath the Earth's surface. Both earthquakes were classified as shallow earthquakes, occurring at depths of roughly 22 kilometers and 10 kilometers. Unlike deep earthquakes, shallow earthquakes release their energy much closer to the surface. As a result, the seismic waves lose very little energy before reaching cities and towns, producing much stronger ground shaking. This intense shaking can destroy buildings, damage bridges, rupture roads, and break underground gas and water pipelines within seconds. Scientists believe the first earthquake transferred enormous stress to a nearby fault, triggering the second and even more powerful rupture only seconds later. This process, known as stress transfer, explains why seismic doublets are considered especially dangerous. Instead of experiencing one major shock followed by weaker aftershocks, people are struck by two devastating earthquakes almost simultaneously, leaving virtually no opportunity to evacuate or seek safety. The disaster also highlights Venezuela's unique geological setting. The country lies along the boundary between the Caribbean plate and the South American plate, where massive sections of the Earth's crust are constantly pushing and sliding against each other. Over time, enormous stress builds up along these fault lines until it is suddenly released in the form of an earthquake. This tectonic boundary has made northern Venezuela one of the most earthquake-prone regions in South America. For millions of Venezuelans, those 39 seconds changed everything. Homes were reduced to rubble, lives were forever altered, and entire communities were left facing the enormous challenge of rebuilding. At the same time, scientists continue studying this rare seismic doublet to better understand how such events occur and how future disasters might be predicted or their impacts reduced. It serves as a powerful reminder that beneath our feet, the Earth is constantly moving, and sometimes it unleashes its incredible force without any warning.